Okay, so let's finish 2.3. Besides whether or not something is a function, finding domain and range, the other primary thing you will be doing is evaluating a function. So for any function f of x, the meaning f of 1 is the value of the dependent variable and the independent variable is 1. Basically, you're plugging in 1 for x, seeing what the output is. When evaluating at a value, your answer should end up being a value. When you evaluate at an expression, it should be an expression, at least in one variable. So let's look at these. F of x equals negative 2x squared plus 3x plus 1. Find f of 2. So again, what's the difference between these two things? F of x and f of 2. The x becomes a 2, which means all of the other x's should become 2's. So f of 2 is negative 2 times 2 squared plus 3 times 2 plus 1. Now a quick little tutorial. You may have heard PEMDAS before, but let's be clear. It's not really PEMDAS the way you learned it in order. Parentheses first, yes, if there's an operation inside the parentheses, then exponents. Then you multiply and divide going left and right, and you add and subtract going left and right. So here there's no actual operations in this side of the parentheses, so we'll do exponents first. 2 squared is 4. To our multiplication, this is negative 8 plus 6 plus 1. If we add left to right, this is negative 1. So f of 2 is negative 1. Plugging in a half, f of 1/2, negative 7 times 1/2 plus 5. Now remember, negative 7 is really negative 7 over 1. This is negative 7/2 plus 5. 5 is really 5 over 1, so we can multiply by 2 over 2. It's negative 7/2 plus 10/2, which is 3/2. So that means f of 1/2 is 3/2. And what does it look like when we plug in an expression? So an expression, remember, is going to be something else with a new variable, whether it be the same variable or something different. Let f of x equals negative 3x plus 4. Find f of m plus 3. So we're replacing x with m plus 3. So we're replacing the other x with m plus 3. Here you're going to have to distribute negative 3m minus 9 plus 4. Just negative 3m, combining our like terms, minus 5. Now what you have to do here, more than anything else that I see, is resist the urge to do anything with this, set it equal to 0. I see that a lot. This thing is done once you've simplified. You plugged in an expression, you got a new expression. Unless all of the values of that new variable cancel out, you should be getting an expression. Okay, another thing is converting to functional notation. Sometimes you're given this equation in terms of x and y, and it asks you for f of something. What you really have to do is just get y by itself, and your y is your f of x once we sub it out. So if I solve, let x plus 2y equals 16, find f of 11. That's basically a fancy way of saying let x equal 11 and find what y is. However, we can also say 2y equals negative x plus 16, means y equals negative 1/2 x plus 8, and say, well, y is really just f of x once we've gotten it to this point, and then plug in 11. Negative 1/2 times 11 plus 8 is negative 11/2 plus 8, which is 16/2, which is 5/2. It's f of 11 equals 5/2. What is a different way we could have done this? Again, we're plugging in 11 still for x, and we're just trying to find what y is. If we had done that originally, 11 plus 2y equals 16. Subtract 11. 2y equals 5, so y would be 5/2. Again, same idea here. I think this way is easier if they say let, but if they want it in function notation, that's just how you would convert into function notation, get y by itself. So again, we can do this both ways. On B, 2x minus y equals 3, find f of 5. Now, again, that would be negative y equals negative 2x plus 3, so y is 2x minus 3, which means f of x is 2x minus 3. If we're doing function notation, plug in 5. F of 5 is 2 times 5 minus 3, or 10 minus 3, so f of 5 is 7. Now, if we had done it the other way, just plugging in for x, we have 2 times 5 minus y equals 3, or 10 minus y equals 3. So negative y would be negative 7. Subtracting the 10 to the other side, we'd still get y equals 7. So again, the same answer. And that's all for 2.3.